Okay, last page of the I/O notes, page 14. So sometimes you're kind of stuck and you're writing an ISR and you need to use a function that is not reentrant. So there's a trick to enable you to do that. If you think about it, the problem is that you're getting preempted and then you're running something else, and so you get overlapping copies of this non-reentrant function. How can you prevent that? How do you prevent the preemption? And the answer to that is disable interrupts, and you can do that. So disable interrupts to use a non-reentrant function in an ISR. It's kind of wordy. So here's an example. So here's my ISR, or my IRQ handler in ARM parlance. And let's just say we're doing something, and next we want to invoke countup to disable interrupts. There is a library function we can use called _disable_IRQ, and then I'm going to put braces here. This is a trick from the course notes that isn't necessary, but I think it's a good idea. So here we invoke countup, and normally you do something with the return value, but I'm just keeping this simple. And then we need to re-enable interrupts. If you leave them off permanently, your system's not going to function. Now, brace brackets, you can actually stick them pretty much anywhere in your code. They allow you to group multiple statements. So with something like a while loop, you can have a while loop where it just has one statement for the body, same for an if clause, else clause, that kind of stuff. Or you can put a bunch of statements in braces. Here it's just being used to kind of demarcate the area where interrupt requests are disabled and enabled. And I'm just going to say that this makes the system unresponsive. So, if you get a high priority interrupt request from an I/O device and you've got interrupts disabled, you're not going to be able to respond to it immediately, not until you enable them. So it makes the system unresponsive, so use sparingly. Best is not use it at all. If you do have to use it, just make sure that is for a very short duration. Okay, so these two functions, disable IRQ and enable IRQ, they're both part of the SimSys library. And you'll have seen the SimSys term in the lab videos, and I might have mentioned it before too. And SimSys stands for Cortex, so it's for the ARM Cortex family of processors, the 1, 2, 3, 4, and so on. So it's Cortex microcontroller software interface standard. So ARM has provided this library that you can use when you're developing code on any ARM processor, and it gives you these kind of low-level fundamental things which are very useful. Okay. we'll see a bit of, well, the operating system that we're going to use in Lab 3 and in the, when we get to the scheduling part of the lecture notes is a SimSys. It corresponds to a SimSys real-time OS standard, or an API, application programming interface, but we're not there yet. So just a note, there's a number of C functions that are not reentrant. Examples of those are printf and malloc. Those are two that, you know, get used fairly frequently. These are not reentrant. As of the C11 standard, they are thread safe. If you look at the documentation on printf and malloc, it will state if it's MT safe or multi-threaded safe, or the other one is asynchronous. I forget, asynchronous something safe, so AS safe or something like that. Anyway, so if it's truly reentrant, it would be async safe. It's not. What they've done is they have added mutexes to the code, which basically locks out different parts of the functions whenever. Whenever they're accessing the global state, they make sure that there aren't overlapping accesses. One of them will get blocked. So we'll talk about mutexes in the synchronization section of the course, which is in the third quarter. So this is the end of the IO note.